Lesson 4.4, Parallel and Perpendicular Lines. Our essential question for today is how do you write the equation for a line that is parallel or perpendicular to a given line through a given point? So we're going to be given a line and then a point that is not on that line, and we are going to have to write an equation for a line through that point that's going to be parallel to the original line or perpendicular to the original line. So these are kind of tricky. For starters, I just want to review. So I have a bunch of lines written on the left, and I want you to look at the slope. So look for the slope in each of those lines, and then I want you to remember what we learned about parallel slopes and perpendicular slopes. So parallel slopes stay the same, and perpendicular slopes flip and change. So remember, that means flip means the reciprocal and change means change signs. So two things are happening. So my original slope on the first line is 3. So if my new line was going to be parallel to that, I would keep my slope 3. If it's perpendicular though, I make it a fraction, I flip it over, and change the sign for my new slope. The next slope is 2/3. So parallel slope stays the same, perpendicular, flip, and change. The third one is -5. So parallel stays the same, perpendicular, I put a 1 under it, flip it, and change it to a positive. -3/4 would turn into +4/3. 1, remember that when we wrote 1 as a fraction and flipped it and changed it, it just turned into -1. -1 then, if we flip it and change it, it turns into +1. And the last one, 4, would be -1/4. Okay, now here's what's new. We need a line that is going to be parallel to this line right here, and it has to go through this point, So right now, I could graph that line. That line is going to have an intercept of 1, and the slope goes up 2/1, up 2/1, and I could draw my line. So it has to be, my new line has to be parallel to that line. It also has to go through the point 3,1. So right here. So what I'm going to do is, I'm going to take that original line and identify the slope. The slope, sorry about that, here's my original line. So the slope of my original line is 2. I'm going to keep the slope 2 because it said parallel. Parallel slopes stay the same. Now I'm going to use that new slope and the point that is given, which is 3,1, to write my equation. I like to write my equation in point-slope form when I know the point and the slope. So here's point-slope form. I'm going to plug in my values. Slope is m, and my point is x1, y1. So y minus 1 equals 2 times x minus 3 would be my equation. I'm going to turn it into slope-intercept form, so I'm distributing on the right-hand side, and then I need the y by itself, so I add 1, and I get y equals 2x minus 5. So if I graph 2x minus 5, my intercept is down 5, my slope is up 2/1, and as you can see, my line is going to go right through the point that it was supposed to. So this is my solution. This line is parallel to the original line, and it goes through the required point. Next example, we're parallel again. It has to go through this line. 2x plus 3y equals 6 is not written in slope-intercept form. I have a couple of options. I could solve for the intercepts to graph this line, but I prefer to work with slope-intercept form. So I am going to rewrite this equation, like in chapter 2, literal equations, into slope-intercept form. Remember, the order is very particular, so the negative 2x needs to come before the positive 6, and then I divide everything. So my result is negative 2/3 x plus 2. So I can graph this original line. My intercept is 2. My slope is negative 2/3. So down 2 over 3 to the right. And here's my original line. Now from that original line, remember, I need to keep my slope the same. My slope the same because parallel lines have the same slope. So I keep my slope, and I've got a new ordered pair to use. My ordered pair is 4, negative 1, and I'm going to plug them into point slope form. So y minus y1 equals the slope times x minus x1. When I substitute my y1 value, what's going to happen is y minus negative 1 turns into a positive. It's a chunky plus. So here's my equation. I can distribute. So y plus 1 equals negative 2/3 x. Multiplying negative 2/3 times negative 4 would give me a positive. I can put a 1 under my negative 4, so it's going to give me a positive 8/3. Positive 8/3. So I might want to look at that instead. 8/3 is the same as 2 2/3. So when I subtract 1, 2 2/3 minus 1 is going to be 1 2/3. So plus 1 2/3. Okay. To graph this second line, my intercept is 1 2/3. That is just below 2, so my line is really going to be close. When I go down 2 over 3, it's going to be just below again. So these lines are not only parallel, but they're almost the exact same. All right, the next example. What has changed now is the word parallel turned into perpendicular. So my original line, when 4th x plus 7, I'm going to have to find the new slope now, because perpendicular slopes flip and change. So I have to take this 1/4 and turn it into negative 4 over 1 or negative 4, because my new line has to be perpendicular to the original. The original one starts at 7, and the slope is 1/4, so up 1 over 4, or I can reverse that. So here's my original line, and it's supposed to go through negative 2, 3, my new line. Okay, so got my new slope. So my slope is m. I've got my point, negative 2, 3, so x1, y1, and I can substitute in point slope form. So change the slope first. That's the only difference on the perpendicular problems. We have to change the slope first. So y minus 3 equals my new slope, and then x minus negative 2, which turns into a chunky plus. Distribute the negative 4, negative 4x minus 8 equals y minus 3. Add the 3 to get slope-intercept form, and you'll get negative 4x minus 5. So my intercept is negative 5, and my slope is negative 4, or negative 4 over 1. if I go down 4/1, it's not going to get me any closer to that original line. So I need to reverse my slope, up 4, back 1, up 4, back 1, up 4, back 1, like that. Oop, that one's off. Like that. And now my new line forms a 90-degree angle with my original one. And it went through the point that was required. On the example before this, 4, -1, positive 4, -1 is right here. So you can see that that new line did go through 4, -1. I forgot to point that out. Okay, our last example. So 3x minus 2y equals 6. We're going to have to do some work to find the slope because this is not in slope-intercept form. So subtract 3x. So negative 2y equals negative 3x plus 6. Remember slope-intercept order. And then be careful dividing everything by -2. So my slope turns out to be a positive 3/2 and my intercept a -3. Remember that 2 negatives when you're dividing turns into a positive. Start at -3 and I'm going to rise 3, run 2. To get my original line. Now my new line, -4, -5 is right here. So maybe I want my line to go even further on my original. Okay, so -4, -5. So my new slope is going to be -2/3 because I had to flip and change it. And -4, -5 is my ordered pair. So my slope is m, x1, y1, and now I can plug it in point slope form. So y minus -5 turns into y plus 5. My new slope is -2/3. And then x minus -4 would turn into x plus 4. If I distribute, I get -2/3 x minus 8/3 y plus 5 equals. Remember that our 8/3 or -8/3 is -2 2/3. So when I subtract 5, I will get -2/3 x minus 7 2/3. So my intercept is starting out at -7 2/3. So that's just above -8. And my slope is down 2/3. Right here. Or up to back 3. Right here. So there is my perpendicular line. It goes through the blue point that it was supposed to, and it forms a 90-degree angle with the original line. You can write a summary now, answering our essential question. And here are your homework assignments. Be careful with the directions. One part works with parallel lines, and the other part works with perpendicular